Okay, so when you see here estimate the acceleration, okay, it is going to be an estimate because we've got a speed time graph, right, or a velocity time graph, same thing. And essentially to work out the acceleration, you need to draw a tangent here, okay, at that particular point where t is 20 seconds. And we then calculate the gradient, and the gradient is the acceleration. Now, to draw a tangent, okay, you've got to do it by eye. So you go to where t is 20 seconds, which is here, okay, and you get your ruler, okay, and you get the ruler so that it goes in the same direction as the curve, okay. It's got to have the same sort of slope of the curve at that particular point. So take your time on it, right? Just look at the way the curve is, the sort of the direction of the curve at that particular point, and then your ruler is going in the same sort of direction. Okay, and then you can draw your tangent. Your tangent will touch there at t equals 20. Okay, so we're doing it by eye, which means everybody's tangent might be slightly different. Okay, but if you're doing a good job of it, you're going to get a very similar answer to sort of this approach here now, because the tangent's really good here. It touches the curve when t is 20. Now the next job now is to work out the gradient. You need to pick 2 points on this line. Okay, so pick 2 nice points, right? Don't pick points that are difficult to sort of measure now in a minute. Like that point there is really nice because it goes through lovely values. You've got 35 year seconds, and the speed is 5, so that's really good. Picking another point, let's see where else we can go through. There maybe we've got 2.6 there, it goes through. Okay, that's quite nice, and that's after 10 seconds. So you've got 2 points, you need to then draw a triangle. Now you can either go across and then up, or you can go up and across. It's your choice. I prefer to go up and across like that way, so you've got my triangle above the line, keep this area clear, okay? It'll help for part B. So if I go up, and I need to go all the way to the top in this instance, don't I? And then across. So let's see how much I've gone up. Well, I've gone up from 2.6 to 5, yeah? 2.6 is what that value is to 5, so I've risen 2.4 if you take them away. 5 take away 2.6, and I've gone across, so I've gone from 10 to 35, so I've gone across 25, haven't I, from 10 to 35. So when I then work out the acceleration, it is simply, as I said, the gradient of the curve at that particular point. So you've drawn your tangent, and to work out the gradient, it's always the rise divided by the run across, or sometimes we call it the step across. I like to use the word step because it's alphabetical order then, isn't it, in terms of writing this, so we can remember rise is on the top because R comes before S in the alphabet, so step on the bottom. Of course, the other way of thinking as well, you know, you rise to the top, so rise is on the top there. Now, how much have we risen by then? Well, that's 2.4, and we've stepped across by 25. So we're going to work that out on our calculator, and I get my answer to be 0.096. Okay, now we've done it. They don't ask for the units. Sometimes they do. So if they ask for the units, little trick here, right, to remember, they're giving you the units of speed here. So the units for acceleration are very similar. So you can write that down to start with, m/s, meters per second. But acceleration is meters per second squared. So you literally put a power 2 there with the s, and you're done.